NEC Section 210.21b addresses the requirements for general-purpose branch circuits in locations other than dwelling units. It states explicitly that these branch circuits must be rated 20 amps or more. This is a fundamental requirement in the National Electrical Code, playing a crucial role in ensuring safe and reliable electrical installations, primarily in commercial buildings. To fully understand the implications of this regulation, it's essential to break down the key components. Firstly, the term general-purpose branch circuits refers to circuits that supply power to a range of outlets for lighting, appliances, and other general electrical equipment. These circuits are commonly found throughout commercial buildings and are distinct from dedicated circuits that serve specific high-demand equipment. Secondly, the phrase other than dwelling units clarifies that the 20 amp minimum rating applies specifically to commercial, industrial, and institutional settings, not residential homes or apartments. Dwelling units have their own set of requirements outlined elsewhere in the NEC. Thirdly, the requirement that these circuits be rated 20 amperes or more establishes a minimum standard for the circuit's capacity. This means that the circuit breaker or fuse protecting the circuit must be rated at least 20 amps, and the wiring and associated devices must be capable of safely handling this level of current. The rationale behind this regulation is based on several factors related to the electrical demands and usage patterns in commercial buildings. Firstly, commercial environments often have higher electrical loads than residential settings. Businesses may operate a variety of equipment, including computers, printers, machinery, and specialized lighting systems, all of which contribute to increased power consumption. Secondly, commercial buildings tend to have longer hours of operation compared to residential homes. This extended usage places a greater demand on the electrical system and necessitates a higher level of capacity and reliability. Thirdly, the potential for simultaneous use of multiple electrical devices is higher in commercial buildings. A single circuit may need to support multiple employees using computers, operating equipment, or running appliances concurrently. A 15 amp circuit may not be sufficient to handle this combined load without tripping the breaker or creating a safety hazard. Fourthly, a 20 amp circuit provides a greater margin of safety against overloads and voltage drops. Overloads can occur when the current draw exceeds the circuit's capacity, leading to overheating and potential fire hazards. Voltage drops can result in equipment malfunction and reduced performance. A higher rated circuit can better accommodate fluctuations in demand and maintain stable voltage levels. To comply with NEC Section 210.21b, several practical steps must be taken during the design and installation of electrical systems in commercial buildings. Firstly, it's crucial to accurately calculate the anticipated electrical load for each branch circuit. This calculation should take into account the power requirements of all connected devices and appliances, as well as any potential future expansion. Secondly, select the appropriate size conductors for the 20 amp circuits. The NEC provides tables and guidelines for determining the minimum conductor size based on the ampacity rating and the type of insulation. Thirdly, use 20 amp rated receptacles and other wiring devices. These devices are designed to safely handle the higher current levels and are typically identified by a specific marking or color code. Fourthly, install 20 amp circuit breakers or fuses to protect the circuits from overloads and short circuits. These overcurrent protection devices are essential for preventing damage to the electrical system and reducing the risk of fire. In addition to these installation practices, it's important to consider the overall design and layout of the branch circuits. Distribute the electrical load evenly across multiple circuits to prevent any single circuit from becoming overloaded. Avoid long circuit runs, as these can lead to voltage drops and reduced performance. Use dedicated circuits for high-demand equipment, such as HVAC systems or large appliances, to minimize the risk of interference with other circuits. It's also important to note that there are some exceptions and specific requirements related to NEC Section 210.21b. For example, certain types of equipment, such as lighting fixtures with specific energy-saving features, may be permitted to be connected to 15 amp circuits. However, these exceptions are typically limited in scope and must be carefully evaluated on a case-by-case basis. Furthermore, the NEC may have additional requirements for specific types of commercial buildings, such as healthcare facilities or data centers, where higher levels of electrical reliability and safety are required. In these cases, it's crucial to consult the relevant sections of the NEC and any applicable local codes or regulations. The enforcement of NEC Section 210.21b typically falls under the jurisdiction of local electrical inspectors. During inspections, these professionals will verify that the branch circuits in commercial buildings comply with the 20-amp minimum rating and that all other applicable requirements are met. Failure to comply with this regulation can result in fines, delays in construction, and potential safety hazards. To ensure compliance, it's advisable to work with qualified electrical contractors and engineers who are familiar with the NEC and local codes. These professionals can provide guidance on the design, installation, and inspection of electrical systems in commercial buildings. They can also help to identify and address any potential code violations before they become a problem. In summary, NEC Section 210.21b is a critical regulation that mandates a 20-amp minimum rating for general-purpose branch circuits in commercial buildings. This requirement is based on the higher electrical demands, longer hours of operation, and potential for simultaneous use of multiple devices in commercial environments. Compliance with this regulation is essential for ensuring safe, reliable, and code-compliant electrical installations. By understanding the key components of NEC Section 210.21b, following the appropriate installation practices, and working with qualified electrical professionals, commercial building owners and operators can ensure that their electrical systems meet the highest standards of safety and performance. In addition to the core requirements of NEC Section 210.21b, several related code sections and best practices can further enhance the safety and efficiency of commercial building electrical systems. Firstly, NEC Section 210.24 provides guidelines for the permissible loading of branch circuits. This section specifies the maximum allowable load that can be connected to a 20-amp circuit, taking into account the type of load and the operating conditions. Secondly, NEC Section 210.25 addresses the requirements for common area branch circuits in multi-occupancy buildings. This section ensures that common areas, such as hallways and lobbies, have adequate electrical capacity to support lighting, security systems, and other shared equipment. Thirdly, NEC Section 210.19 specifies the minimum conductor size for branch circuits. This section provides tables and formulas for determining the appropriate conductor size based on the ampacity rating, the length of the circuit, and the type of insulation. Fourthly, NEC Section 210.12 requires the use of arc fault circuit interrupters, or SIs, in certain locations to protect against electrical fires. SIs are designed to detect and interrupt arc faults, which are a common cause of electrical fires. In addition to these code requirements, several best practices can further improve the safety and efficiency of commercial building electrical systems. Firstly, regularly inspect and maintain electrical equipment to identify and address any potential problems before they become serious. Secondly, use energy-efficient lighting and appliances to reduce overall power consumption. Thirdly, install occupancy sensors and timers to automatically turn off lights and equipment when they are not in use. Fourthly, provide adequate ventilation and cooling for electrical equipment rooms to prevent overheating. Fifthly, implement a comprehensive electrical safety program to educate employees about electrical hazards and safe work practices. Sixthly, conduct regular electrical audits to identify areas where energy efficiency can be improved. Seventhly, use surge protection devices to protect sensitive electronic equipment from voltage spikes. Eighthly, properly ground all electrical equipment to minimize the risk of electric shock. Ninthly, label all electrical panels and circuits clearly to facilitate troubleshooting and maintenance. Tenthly, keep electrical panels and equipment rooms clean and free of obstructions. By implementing these best practices and adhering to the requirements of the NEC, commercial building owners and operators can create a safe, efficient, and reliable electrical system that meets the needs of their business.